There's a quiet revolution happening right now. It's not in a boardroom or on a battlefield, but in the hidden world of medical laboratories. It's a place where machines are actually learning to see diseases and algorithms are predicting medical crises. The very way we diagnose illness is being transformed by artificial intelligence. But to really get why this matters so much, we first need to understand the sheer scale of the challenge these labs are up against every single day. I mean, just look at that number, 200,000. Some of the biggest automated labs are handling that many patient samples a day. And remember, those aren't just tubes and barcodes. Every single one is a person, a family, waiting for an answer. The pressure for speed, for volume, and for absolute, rock-solid accuracy is just immense, and that is exactly where AI is stepping in. So here's how we're going to break it all down in this explainer. We'll start in what I like to call the unseen engine room of medicine. Then we'll watch this quiet revolution begin and see AI in action with some amazing real-world examples. We'll get into the crucial partnership between humans and machines, face the challenges that are still ahead, and finally, take a look at the future of diagnostics. We rarely think about it, but the clinical lab is the absolute foundation for almost every major medical decision. But with more and more tests being ordered and a real shortage of skilled professionals, labs are under incredible strain. They need smarter, faster ways to get the right answers to the right people. So this brings us to the lab's new partner. And let's be super clear here. This is not science fiction. This isn't some far-off promise. Artificial intelligence isn't the future of laboratory medicine. It's very much the present. It's already here, woven into the daily workflow of the modern lab. Okay, so what are we actually talking about when we say AI? Well, these terms get thrown around a lot. Artificial intelligence, or AI, is the big umbrella idea. Basically, a machine doing something smart. Under that umbrella, you have machine learning, where systems aren't just programmed, they actually learn from data. And a really powerful part of that is deep learning, which uses these complex networks, kind of like a human brain, to spot tiny patterns in huge amounts of data, especially images. Think of it like this. AI is the whole car. Machine learning is the engine that makes it go, and deep learning is a super high-performance engine, custom-built for navigating the complex world of medical images. So how does a machine actually learn to do something like read a blood slide? Well, in the most common method, you basically teach it like a student. First, you feed the AI millions of examples, say blood cell images that have all been perfectly labeled by expert scientists. The AI then crunches through all that data, learning the visual clues for each cell type. Once it's trained, it can start classifying new images it's never seen before. But here's the most important step. A human scientist always validates the AI's work. This human in the loop is the ultimate quality control. It's what makes this tool not just powerful, but safe. All right, enough with the theory. Let's get into the really cool stuff, seeing how this technology is actually being used in the real world. We're talking about going from lines of code to making a real difference in the clinic, saving time, improving quality, and in some cases, truly saving lives. Let's start with the blood film. It is one of the most information-packed tests in all of medicine, but wow, it takes years of training to become an expert at reading one. But now you have these AI platforms that can automatically scan a slide, pre-classify all the cells, and then serve them up to a scientist for review. And the results are just incredible. We're talking 90 to 95% agreement with human experts on normal cells. This doesn't replace the scientist, it gives them superpowers. It lets them focus their amazing expertise on the really weird, complex, and critical cases. And it's not just about diagnostics. AI is becoming predictive. Take sepsis. It's a deadly condition where every single second counts. AI algorithms can now watch a patient's data in real time, their lab results, their vital signs, and they learn the subtle patterns that often come before a crisis. Then they can generate a risk score, basically flagging a patient for doctors hours before they might otherwise notice a problem. This is AI directly connecting lab data to patient survival. It's incredible. And in pathology, the world of tissue analysis, the impact is profound. We're talking about deep learning models that can scan high-resolution images of tissue and detect and grade cancers with an accuracy that can match, and in some cases, even beat human experts. To put that into perspective, this technology is essentially democratizing expertise, making a top-tier level of analysis more widely available. And as you can see from this table, the applications go way beyond just flashy diagnostics. Look at workflow automation, things like AI automatically reading bacterial culture plates in microbiology. Now, that might sound small, but when you do that thousands of times a day, it shaves precious time off each diagnosis, which means thousands of patients get the right antibiotic faster. So this all leads to the big question, right? The elephant in the room. Is AI coming for the jobs of lab professionals? Well, the overwhelming answer from experts in the field is a resounding no. The story here isn't about replacement. It's all about partnership. It's about augmenting human expertise, not making it obsolete. And the key is to understand their different strengths. And AI is just brilliant at finding patterns in huge amounts of data. It's incredibly fast, it's consistent, and it can work 24/7 without ever getting tired. But what does the human provide? Well, everything else that really matters: the clinical context, the critical judgment, and, this is huge, the ability to spot something new or weird that the algorithm was never trained to see. The human provides the wisdom, the AI provides the tireless horsepower. This whole idea is summed up perfectly by Dr. Christopher Garcia at Mayo Clinic Laboratories. He says, AI should be a colleague, not a replacement. The best tools are the ones that are built with the lab professionals who are actually going to use them every single day. All right, now, for all this incredible promise, let's be real. The path to getting AI everywhere in medicine isn't exactly a smooth ride. To build trust and make sure these tools are safe and effective for everybody, we have to be really honest about the challenges. So, is this technology perfect? No, absolutely not. And understanding its limits is every bit as important as understanding its potential. And these hurdles are pretty serious. You've got technical things like data bias. Then there's the black box problem. That's when an AI can give you the right answer, but it can't really explain how it got there. In medicine, that's a big deal. And of course, there are the practical things like cost, regulations, and all the ethical questions around data privacy. Let's really drill down on what might be the biggest challenge of all: data bias. Imagine an AI tool that's designed to spot skin cancer. If it was trained almost entirely on data from light-skinned patients, how well do you think it's going to work on a patient with darker skin? The answer is probably not very well. This is why you can't just buy an AI off the shelf and plug it in. It has to be validated locally on data that actually represents the patients it's going to serve. But here's the thing. Even with all those challenges, the future of diagnostics is absolutely being written by this technology. Once we overcome these hurdles, we're stepping into a new era of medicine that is way more personalized, more predictive, and more powerful than anything we've seen before. So, what's the ultimate vision? It's not a future of dark, automated labs with no people in them. No way. It's a future of augmented laboratorians. A future where AI is a cognitive partner, sifting through massive data sets to find patterns a human could never see on their own. And that partnership is what's going to unlock the true promise of personalized medicine. And that just leaves us with this final, really exciting thought. When you combine deep human expertise with the raw power and speed of artificial intelligence, you're amplifying our ability to understand disease. So the real question isn't if AI is going to change medicine. The question is, with this powerful new partnership, what medical mysteries are we going to solve next?